In today's lesson, we shall be looking at the determinant of a matrix. So in doing that, we are going to consider these three matrices: matrix A, matrix X, and then matrix B. If matrix A, B, and X are in such a way that the product of A and X is equal to B, then we can write the matrix equation for these three matrices as. So we have matrix A, which is this, and then we have matrix X as that, and then we have matrix B as. So we can write the matrix equation for this as that. Now let's multiply the matrix on the left hand side. So in doing that, we are going to get AX plus what BY, and that is equal to what G. Then we have CX plus GY, and this is equal to F. At this point, realize that we are having two systems of equation. So let's call this equation 1, and then let's call this equation 2. Since it is two systems of equation, we can solve for the value for x and the y that satisfy these two equations. So in doing that, we can use the elimination method to find the value for x and y. So let's multiply equation 1 by c and then equation 2 by a. So we have equation 1 by c, and that is going to give us what? ACX plus what? BCY, and that is equal to what? EC. And then we are going to multiply equation 2 by A, and that's going to give us what? ACX plus ADY, and that is going to equal to AF. Let's call this equation 3 and then equation 4. So we are using the elimination, right? So let's subtract equation 3 from equation 4. So that is going to give us what? ACX minus ACX plus ADY minus BCY is equal to AF minus what? BC. So from here, you can see that this will cancel this. We have ADY minus BCY, and that is equal to AF minus what? BC. We have y here. Let's factorize y out, and that is going to give us y AD minus what? BC, and that is equal to AF minus what? BC. We are looking for y. Let's divide both sides by AD minus what? BC. We have AD minus what? BC. So this will cancel this. We have our y is equal to AF minus BC, and that is all over AD minus what? BC. Now that we have this, we can substitute y into any of the equations. So let's say equation 1. So we have substitute. So equation 1, we have AX plus BY. So we have AX plus BY, and that is equal to E. We are going to substitute the value for y inside. So we have AX plus B. Our y is what? AF minus BC all over what? AD minus what? BC, and that is equal to G. Now let's eliminate the denominator by multiplying through the equation by AD minus BC. So we are going to have AX multiplying AD minus what? BC plus B multiplying AF minus what? CE BC, and this is equal to E multiplying AD minus what? BC. So let's expand the bracket. This is going to give us A squared dx, and then we have A BCX plus this is also going to give us ABF minus what? BEC. When we expand this, we are going to get ADE minus what? BEC. So from here, you can see that some of the terms can cancel. So you can see that this will cancel this. So we are left with A squared dx minus ABCX plus ABF is equal to what? ADE. So let's transpose this term to the right hand side of the equation, and we are going to be left with A squared dx minus ABCX is equal to ADE minus what? ABF. So from here we have AA. Let's factorize A out. We have SX. Let's factorize S out. We are left with what? AD, and then we are also left with what? BC. And this is also equal to, we can factorize A out. We have ADE minus what? BF. So from here you can see that this A can cancel this A. We are left with what? X. Our interest is to find the value for X. So let's divide both sides by AD minus what? BC. And then we have AD minus what? BC. So realize that this will cancel this. We have our X is equal to DE minus BF all over what? AD minus what? BC. And that is the value for X. We also had Y to be what? Y is equal to AF minus BC all over what? AD minus what? BC. Now let's look at the denominator for these two solutions. With the X, we have the denominator to be AD minus BC. The same thing applies to the Y. We have the denominator to be AD minus BC. Now what do you think will happen to these two solutions when the denominator, which is AD minus BC, is equal to 0? So these two solutions will be undefined. What about when the expression AD minus BC, which is the denominator for these two solutions, is not equal to 0? If this expression is not equal to 0, then the solution for these two systems of equation is going to be a unique solution. So we have what? Unique solution or a consistent solution. So we say that the expression AD minus BC determines the existence or pattern of the solution. So the quantity or the value for this is called the determinant of the coefficient of the matrix. So we call it what? The determinant of the coefficient of the matrix. And the matrix that we use is, we have matrix A with the entries A, B, C, and then D. Then the determinant of matrix A is going to be what? Matrix A is going to be AD minus what? BC, and that is what? AD and then what? Minus BC. And this is how we find the determinant of a matrix. This brings us to the end of today's lesson. See you tomorrow. Bye bye.